I'll do some intros. Looks like it's going. Cool. So I'm here with Zaki Manian and Gun Sirer. Would you prefer Emin or Gun?
Either one is good.
Okay. And Kelsey from Tendermint. We also have a few people in the room who I think are going to be asking questions later on. My name is Billy Rennekamp. I'm grants manager on the board of management at the Interchain Foundation and with the Interchain GmbH. I'm going to be moderating this panel. I've got some lists of questions. Today we have Zaki Manian, wears many hats in the blockchain space, executive director at the Trusted IoT Alliance, co-founder of the Iqlusion validator, expert in cryptography, distributed systems. I'm not going to read the rest of that bio. We have Gun Sirer, a professor of computer science at Cornell University, founder of Ava Labs, co-founder of that Blow X route or Blocks route. Blocks route, probably. The X is capitalized. Co-director of the Initiative for Cryptocurrencies and Smart Contracts, IC3. Would you guys like to give a little more intro background? How you guys doing today? Welcome. Zaki, you always have something to complain about. Maybe you can begin.
Sure, Zaki. Do you want to go ahead and?
Yeah. So yeah, I'm Zaki. I guess what I like doing is like shipping blockchain systems. I like building and shipping blockchains. That's what I like doing. So I'm usually playing with a couple of different things at any given moment. Currently working on the Stargate upgrade for Cosmos and sort of contemplating this thing we call Atom 2021.
Fantastic. So I'm Emin Gun Sirer. I used to be a professor at Cornell. I'm still a tenured professor there, but I'm on leave, and I'm currently heading the Avalanche project. My claims to fame were working on and building the very first proof of work minted coin back in 2002, way before Bitcoin, and then finding the biggest known flaw in proof of work currencies, fixing that flaw to the extent it's possible to fix, and then working on security and lightweight consensus protocols for Bitcoin and so on. I called the DAO hack before it happened. These days I focus on Avalanche and building a next generation platform for all of finance.
That's great. Thank you very much for those. We thought we would begin today with Steelman, where Zaki would explain Avalanche and Ethereum, the EVM chain that's part of the Avalanche ecosystem. And then Emin could explain Tendermint and Ethermint. Then each of you will have an opportunity to correct the mistakes which are inevitable to come in those explanations, and we can use that to sort of kick off. Zaki, would you want to begin since Emin just mentioned Avalanche?
I will take a crack at explaining how I think Avalanche works. So the core, the first big idea of Avalanche is a new consensus protocol that has sort of this like anonymous or pseudonymous origin. That really is like, what's very cool about it is that it basically it uses local randomness, sort of like randomness on your machine to massively increase the scalability of sort of consensus protocol that offers finality. So, prior to this, we have had sort of like a 30-year history of classical consensus protocols that offer thousands of, hundreds or thousands of participants in the consensus. We have recently started to see things like, what Ethereum is trying to do, where you kind of use all kinds of cryptographic tricks to scale your consensus groups for sort of classical style consensuses to larger groups. Avalanche uses this very clever sort of just protocol level innovation that allows you to have like sort of tens of thousands, hundreds of thousands, potentially millions, because of very nice scaling properties in terms of communication overhead and complexity. So that's the one thing that we don't really like from a Cosmos point of view, I'll just about like as kind of view as a trade-off is that the Avalanche consensus protocol doesn't have like a non-interactive proof format built in, whereas classical protocols have like these commit certificates that you can use to non-interactively prove consensus. But out of that, with like sort of this consensus innovation, you have this very nice architecture that you can sort of emerge. So Avalanche will have sort of a root chain where the Ava token will live. And that is kind of like a coordination, staking, Sybil resistance, service discovery layer for the Avalanche network. And then on top of that, you have like a series of subnets. And one of those subnets runs an EVM. So, any, user of the network can, participate in the consensus of sort of the, I don't know what they call it, but I'm going to call it the
subnetworks.
Huh?
We call them subnetworks.
Yeah. So you come to this, you participate in the find the subnet for the EVM chain, discover that EVM chain, and then you get access to a Web3 API compatible EVM that has the that you can build what you normally build on top of Ethereum, but you have this like fast finality, very large number of sort of validators, operators, stakers, whatever, very large consensus group, great censorship resistance properties. And because of the sort of, because you're running this subnet type architecture, you can have sort of horizontal scaling by spinning up additional subnets, should you kind of become like sort of IO limited on your EVM chain. So that's what I think Avalanche and Avalanche EVM is.
That was a fantastic job. I don't know if I can do as great a job, but to recap, Zaki is exactly right. One of the biggest selling points in Avalanche is a brand new consensus protocol. It is the third biggest breakthrough in distributed systems in 45 years of its existence. The last breakthrough came from Satoshi Nakamoto, and then this consensus protocol improves on just about all consensus protocols that came before it. Coupled with a different architecture that Zaki did a very nice job of explaining, which is instead of a single big global network, we have subnetworks, and instead of a single virtual machine, we support multiple virtual machines, each on their own subnetwork. So that makes us very different, and it also makes us ideally suited for DeFi and also for compliant asset issuance. We're all about going after those assets that are not currently in blockchain form, getting them into the chain. So my turn to do this very difficult task. This is so hard, Billy. But Tendermint is probably the first proof of stake protocol founded on a sound foundation. It is based on PBFT, a well understood classical algorithm for achieving quick finality. The authors have also improved, or rather the developers, the architects have also improved PBFT. And I think the master's thesis is one of my favorites, and it easily would have been a publication on its own in the distributed system space, because it really took PBFT, a very well understood, very well studied algorithm protocol, the next step up in improving its efficiency. So it is the foundation for a lot of services because it achieves consensus. From an Avalanche perspective, the limitation associated with all classical protocols is that they do not permit very large numbers of validators to participate. But besides that limitation, the Tendermint idea is that it is using PBFT plus this very cool optimization to achieve quick finality with proof of stake. And of course, also high throughput as well, compared to proof of work chains. And just like every other proof of stake protocol, there is no wasted energy, there is no mining, there's no energy and effort spent on burning the planet down. Ethermint is the EVM supported by Tendermint, as I understand it, and you guys can correct me about what it does and so on. But as far as I understand it, it's essentially EVM plus Tendermint. So it is the EVM coupled with the Tendermint protocol to create a fully, totally ordered Ethereum-like blockchain that is executing the Ethereum virtual machine and is thus capable of being able to run Ethereum smart contracts.
That's pretty good. Zaki, is there any of those points you want to clarify or color?
So all I would say is, so there's a lot of spiritual similarity between the Avalanche architecture and the Cosmos architecture. I think these things are like conceptually similar because this is probably the right way to build blockchains. And both of us have sort of avoided the sharding architecture, where everyone gets randomly assigned to subnets and like subnets reconfigure all the time. And this is for anyone who's sort of been trying to build distributed systems, a nightmare to actually make work. It's super hard. And we think that we both are like, you can get a very useful system without sort of forcing all of this dynamic reconfiguration all the time, and instead have we have Ethermint, which is basically a toolkit for building EVM compatible subnets on top of the Cosmos network. And then we have this IBC protocol that has been sort of the flagship of Cosmos, which is like a system for sort of programs running on one subnet to interact with programs running on another subnet. We call these subnet zones. Mostly, we could have also called them side chains, but we at the time were afraid of the Blockstream trademark on side chains. So, but I think honestly, subnets seems like a really great word for them, and potentially maybe is like where the industry will converge.
So I'd actually like to get into a bit of the way the two projects are similar and different. But before doing that, I mean, you touched a bit on sort of the history of Tendermint as being this extension of PBFT and the sort of work that was done on there. But I would also be similar to ask you about sort of the history of Avalanche and the concept there, and if repeated sampling takes place in other algorithms, or where the sort of like development of that idea took place.
So, okay, that's interesting. So the Avalanche protocol is, as far as I can tell, unique. It is the first of its kind that has been published based on this repeated subsampling approach. So if you look at the distributed systems field, it's been around for not that long, for about 45 years. And the early work in this space started out in the 70s, came to fruition in the 80s, and found, I would say, its ultimate form in PBFT in 1999. And then after that, there were a bunch of refinements on PBFT, a bunch of very cool additions, and Tendermint is one of them, to improve its efficiency. So these classical protocols, they all start out with the foundation that there are a certain number of representatives that speak for all of us, and they will come to a decision. So this small number of representatives have to coordinate, and they coordinate the same way you would coordinate the United States Senate. And in fact, one of the earliest papers in this space is all about a bunch of Greek senators achieving consensus among the senators set. So these protocols are interesting, but they all have the same common feature, which is all-to-all communication. So I'm in a Senate of 100 people or what have you, and to pass a law, I need to collect signatures from some threshold set of participants. That's what these protocols involve. And so that was the base, that was the foundation of hundreds, maybe thousands of academic papers that followed. There were prior to PBFT, there were a bunch of protocols that were far less efficient. And after PBFT, There have been a bunch of refinements to the core idea that made it faster. Along the way, Satoshi came along and said, look, this is all fine, but it's not robust enough. So for his uses and for his open participation, he came up with a different algorithm coupled with a different Sybil control mechanism based on mining. And so that was Satoshi's approach. And I personally have not seen, I have seen in early literature, there is a paper a long time ago from a Cornell PhD student, actually, from the 80s, early 80s, or mid 80s, if I'm not mistaken. There was a paper that looked at repeated subsamples, but it didn't carry the idea through. And it did not prove that, that the Avalanche approach would actually achieve consensus. So maybe I should say a word about how Avalanche works and how it differs from everybody. In Avalanche, you will have some number of people, we call them validators, but they're not like Bitcoin validators. They're not passive onlookers making sure everything got done according to the rules. They are participants. They decide. They are deciders, okay? Think of them like senators, but you might have a million of them, okay? And you're not going to be able to effectively talk to all million, and all million will definitely not be able to talk to another million. You'll get trillion messages. We would clog up the internet as we try to make that kind of a decision. So what happens in Avalanche is you pick a very small set of participants. You ask them something like, hey, I see that Alice is trying to do a double spend. She's trying to spend some money with Bob, and she's trying to pretend that the same money can also go to Carol. So who did she pay? We have to decide which one of these is the official one. So you ask your friends, like say 3 to 5 people, and you flip your own preference according to what results you got from your sampling. So I sample the network. I say, hey guys, 5 of you, what do you think, Bob or Carol? They come back with Bob, Bob, Carol, let's say. And I flip to Bob because there are more Bobs than Carols. It turns out that this dumb process, if repeated for a very modest number of times, will cause the entirety of the participant set, all million of them, to very quickly agree on a single outcome. It is nonsensical. I didn't think that it would make sense to do things this way. This was something that I had been thinking about and mulling around and working on actually with my group. But the proof was authored by a group calling themselves Team Rocket. And so Team Rocket's contribution was to prove that this process would lead to a unitarian outcome, to a single outcome. And so it's a probabilistic protocol. It's potentially possible that you always sample a minority that's trying to trick you, but the chances of that happening are exponentially small the more samples you take. So it's probabilistic, kind of like Bitcoin is probabilistic. It's super efficient. Whereas a classical protocol would send trillions of messages, we would send a very modest number of messages, on the order of a few hundred per node. So that is a pretty amazing breakthrough. And that's the idea behind Avalanche. So there have been other people who came out of the woodwork and who made a bunch of claims about, oh, I came up with that before, blah, blah, blah. I haven't seen it published. So the currency in this game is you publish it. If you keep something secret to yourself, then that's not good enough. If you come up with something and you're skirting around the edges of being able to enunciate, did I come up with, I've got like lots of ideas on it. Every time I go into the shower, I come up with a bunch of rough ideas. Wouldn't it be cool if we had a fluid that was compressible it was not compressible in this direction, and was solid like in this direction, but moved like a fluid in the horizontal direction? That'd be cool. I could flood the streets with it. I could jump onto it and ride on it like a surfboard because it's solid in that direction, but it flows like a fluid in this. Great. I came up with something, but did I really? I have to extract this idea, then I have to tell you exactly how to manufacture that molecule. And if I'm not doing that, then I've got nothing. And if I don't have a proof that this thing will carry you across the street, then I've got nothing whatsoever except a fantasy. So there were a bunch of people who made claims about, oh, we thought of this too. Well, I thought of a lot of loose ideas without being able to show that they work. So the currency here is gotta publish, make it public. You gotta prove that it's correct. And so sorry, you gotta explain what it is. And three, you gotta prove that it's correct. So those three things, if unless you have them, then you don't have anything at all.
Cool. Thank you for that explanation. Yeah, I really love the sort of like elegance and simplicity. And like you said, it's almost like a really dumb thing that ends up having this great property. It actually, part of the question is because I could imagine, and probably in the same way that other people have had this idea in some capacity, is that you might find this in nature or something somewhere, the way that you found like sorting algorithms show up in nature.
Yeah, no, it is inspired by one class of algorithms that are somewhat well known to practitioners. They're called gossip algorithms. So in gossip algorithms, I know something and I want to get it out. And in the old days, so if you look at the early designs of the internet, throughout the 70s and 80s, the way you distribute data was by building a structured thing. So people would build like DNS, for example, best example. DNS works by building a tree structure. There are many other systems that try to build, trees, forests, and so forth, or graphs of different kinds with certain properties. And again, in the late 80s, one of my colleagues at Cornell came up with this idea that, hey, I can use gossip. That is, there is no structure. I just pick a few people and I tell them. They pick a few people and they tell others. And that gossip protocol idea is used universally now for almost every area where you need to disseminate something. Cosmos has this, Bitcoin has this, Ethereum has this for transactions and blocks. Because it's such a powerful idea. It turns out that gossip is much faster than any static tree you can build. And it's much more resilient than any other static tree you can build. So it's inspired by those algorithms. But unlike gossip, in gossip, all I'm trying to do is get the word to you. In consensus, you not only have to know about what Alice intends to do, but if she intends to do multiple things, you and I and Zaki and every good person on earth have to agree on the same thing. It's a substantially more difficult problem.
Thank you for that. So Zaki mentioned this a bit earlier, but at a high level, the projects really sort of are similar in this sort of way that there's this subnet architecture, application-specific blockchains is really the name of the game, and that there's some sort of coordination between them. In the Cosmos world, it's really all about IBC. It's sort of like trusted protocol between going through it, and it seems like the Avalanche world has this sort of like coordinator area that does atomic swaps and helps go through. One of the areas that are really different though, and I mean, also we'll get to, of course, Ethermint and EVM and the similarities in our options in that way. But the two sort of places that I would say are the biggest difference are beyond the literal consensus mechanism is the validator set size and the presence of slashing inside of the proof of stake protocol. Zaki, maybe do you want to begin and talk a bit about like what are the benefits and drawbacks of different validator sets with regard to safety, liveness, and proofs? You mentioned those earlier.
Okay, so I guess a lot of this, so first, I like, I got interested in like consensus protocols in like 2013 when Jay started talking to me about Tendermint. And so like, some of the early like consent, first, like most people who come in the cryptocurrency space, mining was really interesting and exciting. And there's all this game theory. And it's a very like sort of such a simple idea that has such complex implications. And so, spent a whole bunch of time learning about that. Then I started learning about PBFT and like when I was friends with Jay when he started working at Tendermint, learned about Stellar. And basically my thesis, I would argue that sort of Avalanche is sort of like the end of consensus innovation. Like I expect we will see like further refinement on Avalanche, on hot stuff, Tendermint style algorithms, on sort of Stellar federated Byzantine. But I would suspect, I like strongly believe there will be no, like Avalanche is kind of the last breakthrough. So I like that thing is like, it's like just sort of like in the intellectual landscape, it's clearly important. But the other thing is like when I started working on like figuring out how to launch Cosmos, basically validators didn't exist. There were some pre-existing proof of stake protocols, but it was pretty clear that like almost all the nodes were run by, you know, a very small group of like very like sort of centralized entities that were associated with the people who launched the protocol, and maybe like a few other things. Like there's a group in New York called Battlestar, and they were running like one of the early staking operations. But on the whole, it was like their validators didn't exist. And so like 2018 was the year that I spent like basically creating the validator community from nothing. Being like, there's this thing, it's called Tendermint, you can run a validator on it. We think there's going to be business opportunities here. We think this proof of stake wave is coming because we're like creating this technology that will allow like people to make it much easier. And like clearly there will obviously be follow-ons to all the work that we're doing. If it succeeds, you should come and get involved. And you know, in that Riot chat, you know, Figment, Bison Trails, like the whole sort of like now this like giant, you know, multi-million-dollar validator economy sort of came out of all of that work that I did, which was basically like looking at this problem of like, how do you actually bring these things into existence? And what I think of as like the biggest sort of question that is sort of the existential question, and it's like great that people are working on this, of all of these sort of more scalable protocols, is you're going to have to come up with some sort of clever mechanism that sort of 100x's the work that I did in 2018. Because basically I was able to go from like 5 validators maybe at the beginning of 2018 to, you know, hundreds by 2020. But somehow we have to go to like really take advantage of the scalability of some of these protocol innovations. Like we need to figure out how to go like much bigger than that. And I think that's sort of hard to sort of fully wrap my head around. I think the other big question that sort of was a sort of interesting question is, you know, when we first started talking about running like open public networks with like PBFT style algorithms, you know, the conventional wisdom is that they would halt, that they wouldn't be live, that you couldn't, that with like random strangers on the internet, you couldn't keep one of these networks going. And I think one of the things that's been most interesting to see is that, like, you know, based on the last like kind of 2 years of experience, Tendermint style algorithms actually seem to have quite nice liveness properties, because they, you know, the sort of 1/3, you know, of the network must, 2/3 plus 1 of the network must be alive, has survived like, you know, major cloud and internet halts and like disasters and stuff like that. And so that seems to be working. And the other thing that's really nice about it is that like it's very easy to diagnose Tendermint like when it's wrong. You know, like Kava has this, we used to have this when we started with the Tendermint testnets, that, you know, with the Cosmos testnets, that the, you know, like a blame tool, like who's offline. And I think Kava actually just open sourced their blame tool for Tendermint. And like one of the things that I'm really curious about is like, as you scale to like these very large validator sets, and some sort of internet disaster emerges, like how debuggable, how sort of monitorable, how introspectable is the consensus? Because, you know, the whole point of Avalanche is nobody really needs to have a global view of the entire system. And we're going to see, but it's exciting. I'm not trying to like criticize. I'm trying to just say, as someone who's sort of been through the battles of trying to deploy new consensus protocols on the open internet, these are the kinds of things that you're going to have to figure out. Like it halted. How do we figure out why? And that'll be a crazy adventure.
Billy, can I just take a few minutes to just have a love fest and talk about similarities before we go into the differences again? So, you know, one of the things I love about Cosmos, again, in the Steelman spirit, that we share entirely in Avalanche, is this notion that we are different from just about everybody else that came before us. So in what sense, you might ask? And in the following straightforward sense. Almost everybody else that came before us copied their basic network architecture from Satoshi. And what is that basic network architecture? You have one coin, you have one virtual machine, and then you have one network. That's it. So what do? You sell the coin, the virtual machine implements the coin, and then the network executes that virtual machine. So the people who bought your coin, they shill your coin all day long. You've got this network that is of ragtag people. Luke Jr. is in it with his Raspberry Pi that's in the Florida swamps or something, and it's this one size fits all. The rules that this network can possibly execute or abide by are frozen once and for all time, and they're meant to be global and apply to everybody. It's something that has immense political implications, and political ones, not just technical ones. Forget technical stuff. Maybe we can find a patch around it. But the political implication is this: once you have one size fits all, and that size is essentially a bunch of stuff that some techie coded up once in 2009, then you get into this crazy mindset where you say, look, I'm not going to be able to abide by any nation state's laws. And then you suddenly start going down this super slippery slope of down with the state, down with everybody. All I know is the Bitcoin. Whatever is law on Bitcoin is the only thing I recognize. I do not recognize anything else, and so on and so forth, primarily because of a fundamental technical limitation in your network. You had the one coin and then just the one virtual machine and the one network. Where Cosmos and Avalanche differ is that we recognize the need for having multiple networks. In Avalanche, we call them subnetworks. In Cosmos, I think you guys call them zones. And so in many different contexts, you end up having people who want to issue coins of their own that obey a different rule set than the one you came up with. And they want that rule set implemented on a set of nodes that abide by a different contract. For example, you might want to have nodes that say something like, look, on this network, there will not be any tiny little devices. We don't want, Raspberry Pis. We only want large nodes. Why? Because we're going to run really large smart contracts. Or you can say something like, look, on this network, we realize that we have to abide by the GDPR. And everybody on this network has agreed to abide by the GDPR. Or on this network, there is a particular contract that somebody came up with, and everybody has signed on to it. They will abide by the wishes of that person. All of these are possible on Avalanche, and I believe they're possible on Cosmos as well. And pretty much nobody else. I'm not sure what Polkadot is doing actually in this space, but aside from the three of us, I think there are very, very few other chains. I don't know of any other chain actually that can accommodate these differences. And when you start sort of stepping out of the crypto domain, when you start actually looking for financial applications, you find that they all come with this need to control what people say, to control the full asset lifecycle. And if you don't control the network, you can't control the asset lifecycle. So the systems that provide control over the network, like Cosmos, like Avalanche, have the upper hand over ones that are a one size fits all. And I'm really proud of this. That's one of the many reasons why I'm delighted to be chatting here, that we share the same vision.
This is,
Thank you,
just like, can I jump in, Billy?
Yeah.
We've been calling this sovereignty of an interoperable system of this has sort of been our sort of language around this is most systems that run on blockchains are like you don't want to run a system on a blockchain if there are no politics. Like if there are no politics, then like run it on a database. Like databases are great. Like, you don't need a distributed computing system that's decentralized and has independent operators if there are no political components on it. And so, there's this inherent need to be able to tie like what Gun calls the asset lifecycle to the political considerations of the system, while retaining some notion of interoperability between these like political units. And this has been, this is like, I think really where Avalanche and Cosmos like fundamentally philosophically agree that we will accelerate product market fit, where right now there is, right now the blockchain world is basically, you can have interoperability if you decide to give up all control over your asset lifecycle to, or like core parts of control over, to some political entity that you don't really even like understand. Or you like are off in your own island. And what Avalanche and Cosmos are both trying to do is say, this is a false dichotomy. You can have a great interoperability composability story, but retain the ability to kind of have your asset lifecycle based in a system that you actually understand and like has political trade-offs that like, made sense to your community.
This is great. I realize as a moderator, I should be a little less opinionated. I'm going to remove my
Oh, bring it on, Billy. Bring it on.
My background. And I really appreciate sort of you all highlighting that, especially the way the projects rhyme and sort of embrace these different sort of architectural decisions that seem to be working out. I'd love to get a bit more into the differences and the way the different decisions sort of play out. And we spoke a bit about like what are the properties of large validator sets, and obviously just getting validators to fill them is a big part of it. They touched a bit on safety and liveness guarantees. I wonder though, the other sort of big difference is well, one, how cross-chain communication is handled, and I'd like to talk about that, but also how slashing takes place inside of the protocols. Between those two, I'd love to cover both of them. Which one would you all want to begin with, and we can dig in on?
I can go on my rant about slashing. It's pretty straightforward. So the way this whole thing developed, the way the whole blockchain proof of work, proof of stake protocols developed, was very much influenced by Satoshi. So Satoshi came in with his proof of work based scheme, and at the core of that scheme is a Sybil control mechanism that says you got to be burning a crap ton of electricity, you got to be melting down the the polar bear habitat just to prove that you are not masquerading as more than one person. So that's at the core of all proof of work protocols. And so there is an external cost to just about anything you do related to block production in proof of work protocols. And so if you are a bad actor trying to create multiple blocks, there is a cost to it. And in those systems. Now, the straightforward thing that happened from then on was, well, okay, as we move to proof of stake, then what we need to do is emulate some of these costs. And if we see somebody who's trying to sort of denigrate the system, who's trying to damage its ability to make decisions, who's trying to attack our system, well, there has to be a cost associated with that. If we don't have that cost explicitly in protocol, then we're going to be, then people, they would collude and they would try to do bad things to us. And so that's an interesting starting point. It is false. I believe it to be completely false and unnecessary. So slashing is not done in Avalanche. Avalanche has zero slashing and a node can do all sorts of attacks all day long. What it cannot do is, what it will never happen to it is the funds that are associated with staking will never be slashed, will never be usurped by the system. The reason why why I never intended to have slashing in the first place is we want financial systems to be calm. We want what Arthur C. Clarke calls quiet technology, what Mark Weiser calls mature technology that you don't even see and doesn't create anxiety for you. I could not possibly imagine staking my own funds if some kind of a software failure, some kind of a hardware failure, some kind of a configuration error could cause me to lose my funds. I just wouldn't do it myself. And I find it foolhardy that other people do this. So that's my aversion to it. I want to be able to predict my financial future. That's one of the reasons why I love blockchains, is because the human element is minimized, and the things like the supply cap, etc., or the minting schedule are enforced by algorithm. So that's cutting away that human element. And in the same sense, I want to get rid of cantankerous algorithms that can take away my stake. At the same time, there's the technical essence of this is, well, it's not necessary. There are all sorts of reasons for why it's not in your best interest to try to come at, say, Avalanche with an over threshold majority. It would be so costly that the winnings that you would get from doing that would be dwarfed by the cost you'd have to pay. Ergo, I don't have to punish you individually. I know that it would be inconceivable for you to try to attack it, at least if we achieve enough of a market cap. If we're a tiny market cap company, perhaps that's possible. This has been borne out. There have been many attacks possible on Bitcoin for a long time. There have been many attacks possible on a huge number of chains. Only a subset, a tiny, teeny fraction, have actually taken place in the wild. People don't attack these systems. They don't collude and attack these systems in the sort of the manner that one might be afraid they perhaps could. And the reason for this is that these secondary punishments that are not in protocol are actually so strong as to keep those attacks at bay. And finally, in protocol responses to attacks don't actually work. If I'm capable of launching an attack on a protocol that is actually substantial and I'm able to get away with it, then I would just as likely be able to launch the attack on the things that are trying to take my stake away. So it's a misguided effort. I see the Ethereum folks. I think that's where this Ethereum 2.0 people started out going down this slashing path, and everybody else has been going down it as well. The only thing slashing has done, in my view, is taken away money from deserving people who had a software misconfiguration, and they didn't really need to have their funds cut. They would have corrected that error, and those errors did not lead to any problems, at least for the systems that are in consideration. Especially when you have large numbers of validator sets, then the kinds of attacks that we could see are just essentially practically inconceivable. I agree that if you have a very small set, like if you're doing, what Zuckerberg is trying to do, whatever they're calling it these days, Libra. If you're doing Libra and you've got 28 actors, could like 7 of them collude, or 8 of whatever the number is, 9 of them? Could 9 of them collude and take your money away? They could, like 9 people could collude. I believe that can happen. But if you got an Avalanche network of like, 10,000 nodes, would 4,000 of them collude? I think that's incredibly unlikely. So that's my quick rant, delivered very informally. But the bottom line is slashing is technically not necessary, technically not effective, and for a whole bunch of UI UX reasons, for a whole bunch of user experience reasons, not at all desirable. So we just did away with it in Avalanche.
Cool. So I want to be mindful of the time to leave stuff to talk about actually Ethermint, which is what we're here, and the Ethereum. But Zaki, I would love to hear your thoughts on slashing. And if we could also maybe get a bit to the stuff about validator proofs and the difference in how cross-chain communication is handled.
Sure. So okay, so I'll go fast. So my thoughts on slashing is, so I would mostly agree with the idea that no one attacks these systems. We think of a couple of things. One is we think in the IBC model, the attack game theory is significantly more interesting, because as you kind of increase, so in general, consensus attacks are pointless in a world of where the entire economy is self-referential. It's not really that exciting. Like the only people you can double spend in sort of these like, self-referential blockchain ecosystems that exist right now is exchanges. And exchanges usually KYC their customers, and so they can send men with guns after you if you double spend the exchange. And sort of, so in many ways, like, Bitcoin, like as a practical matter, is mostly coming to consensus between like, a dozen exchanges. Like their Bitcoin security is overkill. But things get a lot more interesting once you have interacting blockchains, once you have blockchains that interoperate widely and you have non-native assets, especially if you have permissionless asset, like blockchain to blockchain asset movement, which is like the whole vision of Cosmos, because you can potentially have a mechanism of actually like significantly economically benefiting because you were able to get an asset that like, you were able to like obtain Bitcoin through manipulating the consensus of a Cosmos chain. And sort of this attack surface area is sort of the reason why we've sort of invested so much time and energy in fault detection and slashing capabilities. The second thing is that I really think is one of the things I really worry about the validator ecosystem is the sort of tendency to race to the bottom. The validator marketplace is like a classic like low information marketplace. People don't really know anything about the setups that people are running. It's really hard to verify the security and like sort of verify the overall state of the network. And Iqlusion runs a validator. We've been running a validator since, validators basically existed. And, there's an enormous tendency in this sort of low information marketplace to like invest a lot in marketing and not invest a lot in like operations and security. And if everyone in the network is doing that, and slashing is right now, I think probably the best countermeasure to this. I do agree with the notion that if your numbers are large enough, you can swamp both of these effects, but I don't know how, like, I'm looking forward to someday seeing numbers large enough to convince me this is true. On the interoperability front, so I don't know how Avalanche's interoperability works, but I do have an interoperability protocol for Avalanche that exists within my mind, which may or may not be the actual one. And so the basic Cosmos interoperability protocol is that we have a packet mechanism where chains can send each other messages, except chains can't do anything because they're not, they're just sort of databases. They're not active software. And so what we do is we write consent, we attach to commit certificates these packets, and then we have these untrusted relayers that relay these commit certificates, and then we have on-chain light clients which track the system. The way I suspect Avalanche interoperability will end up working is instead, and then you have these relayers that bridge between the subnets. What I suspect Avalanche is going to end up doing, because they don't have these non-interactive proofs, they're going to end up instead having sort of quorums of nodes that are willing to sort of that are going to be active consensus participants in two subnets, and are going to be like, okay, this message that originated on one subnet that needs to be sent to this other subnet, I can see that there's consensus and finality on that subset, and that there is, and then I can sort of inform the other subnet state machine that finality has been reached. It's sort of potentially a little bit more complex on the networking side than implementing IBC. But it does take advantage of like the efficiency of, it takes advantage of the efficiency of Avalanche to enable interoperability, and the fact that you can like very cheaply be a member of multiple subnets, whereas it's somewhat expensive in Tendermint to be a member of multiple subnets. So instead we use non-interactive proofs.
Right. So yeah, thank you, Zaki. That's exactly right on. So just a couple of additions to that. We can generate non-interactive proofs. It's just not in the Avalanche spirit. So we've been trying to push on the Avalanche approach, which requires no signatures, and that's one of the things that makes it really really cheap. The messages don't accrue a crap ton of signature material. They're just very lightweight, and we try to keep everything essentially in the Avalanche spirit. So the big difference between these protocols, not between the two of them, but between Polkadot and Avalanche, and is at least Polkadot approach is very different. And I don't know, I looked through the IBC protocol in detail a while ago, but I don't know where you guys stand today. But there is one big architectural difference at a very high level. Suppose that I am some company, I'm an IoT company, I'm Siemens or whatever, Philips in Germany, and I want to partner up with my Korean counterpart. So I have a sub network in Germany, and I have a sub network in Korea, and I want to exchange digital assets between these two. The Polkadot approach, at least, is one where both subnetworks have to communicate and go over some kind of a global hub. And in Avalanche, that is not required. And I'm curious, Zaki, now that we're chatting, I don't really, I love talking to you, and I don't get to do it anywhere near as often as I normally do. But now that I have you here, maybe you can explain if what happens in Cosmos. In Avalanche, the two subnetworks would talk directly to each other. There would be no need for going over the Avalanche public network. We facilitate that. We do not tie people down to our token or network. But I don't know what you guys do.
Yep. So the Cosmos philosophy is identical to the Avalanche philosophy in this way, which is, this idea of having, it's like, there's layers of this, which is like, so one layer, the most sort of horizontal layer is there's no generalized service discovery. There's no one place to find any information. And everything is sort of horizontal and ad hoc. And this is sort of the IBC model. And then I think there's going to be a drift towards at least some hubs in this network. That's why we called it the Cosmos Hub, but it is not. It doesn't do this yet, and we might get beaten by the Binance chain or something else. But like one place where service discovery mostly happens, because and we were able to demonstrate this during our Game of Zones, how like complicated it is to actually like figure out where there are how to interact with other subnets, where to look up, like, how do I find a node with a port that's open to talk to this other subnet, because ultimately, like, blockchains exist in this like platonic reality, but like ultimately, like, there's real networking hardware and you actually have to route packets. So what Polkadot is Polkadot is very much like in the sharding family. So that means you have one stateful entity that needs to register every message, that needs to coordinate dynamic reconfiguration of any node. All nodes have to be listening to that coordinating chain and then respond and dynamically reconfigure themselves, join new subnets, sync new state, run new code based on like what this relay chain is instructing. And it's really, really hard to build these things. It's easy to write white papers about how you're going to have like dynamically reconfigurable subnets. And I always say, like, the Tendermint peer-to-peer network works, like, observably. Why it works is something of a mystery. And so if somebody was like, make it a lot better, I'm like, we're not really sure. We always worry about making it worse and it's suddenly no longer working. Like, I'm always shocked that like I send a transaction to like a random node on the Cosmos Hub, and it's like on my validator, like you know, in a fraction of a second. And I'm like, how the hell did this even happen? Like, what topology made this happen? And the answer is we don't really know. We don't have visibility into that yet. But now, you know, if you have all of these, you have all of this dynamically, like you actually care about topology in like of your subnets in a really detailed way, and that stuff is, it's hard to reason about, and it is going to take a lot of work to make one of these things really work, if they ever do.
So something in that discussion that came to mind was inside the sort of protocol paper, it discusses that you kind of register to be a validator in Avalanche, and correct me if I'm wrong about this, but you register to be a validator basically on the sort of primary chain, and you would pay some deposit, and you would say when you want to start validating and for what period you want to validate. This sort of calculates the reward mechanism that ends up showing up. You also designate the signing key as well as basically the recipient key who receives these fees. Does that mean that every validator in the Polkadot system is always a single user, and there's no such thing as delegation for average token holders? And does that mean that you really have the token and the economics of being a validator is much more strictly, I'm an operator and I've invested largely in this token, compared to, you could say, the basic token economic model for Cosmos chains is that you have delegations for users who are not actually operating these validators themselves. Could you speak on the difference in delegation and if that's correct, or if I misunderstood that?
Zaki, I'll let you handle this one. I don't know Polkadot enough, and I don't want to say something incorrect.
Sorry, I'm not asking about Polkadot. I was referring to Avalanche versus Cosmos.
Oh, I can speak to the Avalanche side, and there is a bigger question really, and I don't want to go into too many side rants, but this validator landscape that's emerging that Zaki alluded to, it bothers me. So let me just say a few words about this because it's interesting, I think, and I want people to start thinking about this. There is this new ecosystem of companies that are in the business of holding your tokens and participating in the network for you. And what they really do at the end of the day is they run some code on AWS. And there's a very good question in the chat from Bruno Scorch. Essentially he's pointing out that all of this code is running on AWS. These guys really provide zero added network diversity. All they're doing is they're running the same crap on the same nodes, same set of nodes, and they all share the same fate. So a disaster at AWS will take down potentially a substantial fraction of a network. This is really problematic. And when you look at what they individually do, they're all providing the same exact service. It's just, I run your code. They're not providing striated services. They're not providing differentiated services. One of the very exciting things that we want to do with Avalanche is create a rich ecosystem of validators. There need to be validators that bring something different to the table. What might they bring that's different? Well, take a real estate asset, okay? So suppose you create a real estate asset on Avalanche. Suppose you create it on Ethereum. Let's take a look at that as our baseline, which is a great system. On Ethereum, if you're a participant, if you're a miner, you don't know what you're mining. You don't know that this thing is anything other than a bunch of instructions. You don't even know that it's a coin. It's just an ERC20 for you. And you're just executing the code just like every other instruction that you execute. In Avalanche, the assets are first-class entities. They're supported by the nodes. The nodes that are participating in the ecosystem know what they're doing and know what they're supporting. So if you're in the sub-network that is supporting this real estate token, you know that this thing is a real estate token that requires special handling, or that might require special handling. What kind of special handling? Perhaps archival. Perhaps you should be keeping your records for the next 10, 20 years. Perhaps you got to be doing something very different from running the code as given to you on AWS. So, and for this, you need to be compensated differently. It's not just an Ethereum transaction that you execute for 10 cents or whatever it is, these multiple dollars. It's something different. It requires archival. Maybe you have to print it out. You know, it's real estate. You can charge thousands of dollars for the transaction fee because you know you're doing something special and you know what you're participating in. So this is one of the key differences in how we see this. And I ranted long enough, Billy. I apologize. You started out with a very good, very well-defined project, and I veered off course. Could you remind me where I need to go back onto?
Well, so I read a bit of the Avalanche paper, one of the protocol paper, I think, and it discussed the sort of process of registering to be a participant and the validation process. And that was the sort of role of the central, or I think it's P-chain, or is that the correct term? Yeah.
What platform?
Platform chain. And that the process of registering includes a deposit, duration, and starting time, as well as an address for receiving those fees or rewards, and the key or the address for the actually operating it. And that makes me think that this is basically a one person, one validator system.
Yeah, we would like that. We would like that. You can delegate. In Avalanche, you can delegate. And that's, we've had that feature for a while. We're just in the process of adding limits on how much delegation any single node can receive. But at the moment, you can delegate. And I would very much love it if people did not delegate. This delegation leads to centralization. That's why I went on this rant about AWS. So I don't want some kind of, an AWS mega node. I certainly don't want a couple of, or about a small number of nodes on a centralized infrastructure provider like AWS, providing the backbone of the network. I would very much love it if people ran Avalanche out of their laptops at home. That would be the best outcome. They can, it's possible. And we did everything to facilitate that. But as you know, these networks are emergent things. You sort of put the right force fields in effect. You try to get rid of all the impediments to bad things happening, and then something emerges. And I'm really very much hoping that we don't all centralize these proof of stake chains on the same couple of staking providers on AWS. Then we're back to a database design again. And that would have been a failure in my view. So we're doing everything in Avalanche to avoid that fate.
So I would push back a little bit on this idea of delegation leading to centralization. I mean, isn't the most common sort of logic with delegation is that it removes centralization because it sort of has this capability of a more diverse sort of economic process that you don't just have the wealthy validators who are accumulating more wealth, but you actually distribute the token holdings to a far larger body of interested parties.
I want that to happen. I want that to be true because it would benefit me. But in my view, every time there's a popularity contest, the winners are zip distributed. They're exponentially distributed. There is somebody who's offering either low fees, or there's somebody whose website is snazzy and looks great, and everybody just goes to them and throws their lot in with them. We saw this happen with Bitcoin. Bitcoin ended up having a single miner that exceeded, they had 56% of the mining power back maybe 5 years ago, 4 or 5 years ago. So it happens. It happens because people are not very discerning. So I'm a little afraid of this outcome. But if what you're saying is right, and I want it to be right, then it would be great for us, for both Cosmos and Avalanche.
So Zaki mentioned a bit ago, one of the features of slashing is that it actually gives insight into the sort of status capabilities and real sort of performance of these different validators. You're able to sort of weed out the ones that all just so happen to be clones of the same AWS implementation. You mentioned that you want to sort of have a similar ability to weed out or prevent, just cloned deployments. And as I understand it, the solution to that is that you have the ability to imply or impose requirements on validators for different applications in your subnets. So my subnet can only be run by a validator who proves that they have over 8 gigabytes of RAM or something like that. How do you actually enforce that?
How do we enforce? Sorry.
How do I prove that the validator on my network actually has the required KYC documents or the required hardware requirements?
I see. We do not. That's not something for the platform to do. So it's not something for Avalanche or me to get involved in. This is strictly externalized. So imagine that there's a company, let's say, your prototypical whatever, some company out there that wants to issue a token and wants to build a network to support that token. It's up to them. They can have their own KYC process. They set it up externally. We have zero say, and the platform requires absolutely nothing on that front. We just externalize all of that to whatever mechanism they might want to enforce. And we also do not enforce resource limits. The easiest ways to enforce resource limits is to actually consume a lot of resources. If you're consuming it and there's a validator that can't keep up, they'll just fall out of the network. So there really isn't. I mean, that's a social consensus issue, really, as opposed to a technical issue. So I do not need to check that you have 8 gigabytes of RAM. I'll just blast away at the speed I want to go at, and if you can't keep up, then you can't keep up.
Okay, great. Okay, so we've done about an hour of just comparing the protocols. I realize this is sort of a necessary first step to getting to what we're all here to talk about, but let's maybe begin talking about Ethermint and EVM. I'll just give, or maybe Zaki, would you like to sort of maybe describe a bit of the difference between Ethermint as a module and Ethermint as a potential network, and we talk about how the EVM works on Avalanche and the Ethereum network subnet.
So another way in which Avalanche and Cosmos are very similar is that like Cosmos, the Avalanche team has been building a framework for building VMs for their subnets. So most protocols that we see on in the blockchain space right now have one specified state machine. So a state machine, what is a state machine? So the Ethereum virtual machine is a state machine. It specifies how inputs are going to be processed and how they result in state transformations. And that is sort of what this is the state machine concept in the in like blockchain protocol design. So we built the Cosmos SDK. The Cosmos SDK is a framework for building state machines. Cosmos SDK has this notion of modules. And so we have modules for things like staking and fee distribution. And what we've been working on in partnership with ChainSafe, and ChainSafe has honestly been doing most of the work, is taking the Ethereum virtual machine and making it a module inside of the Cosmos SDK system of modules. And so when someone spins up a new Cosmos network, what they do is they take the existing modules, they add their own, they can modify them at will. You can have something that is 90% like Ethereum's EVM, but potentially implement some EIPs that Ethereum hasn't yet, or sort of veers off in a different direction. You get this custom, but you can customize and mix these things and get sort of a state machine that works the way you want to. And the Avalanche team has really beautiful docs for their state machine building framework. And as far as I know, these are the only two of these things that exist, which is like sort of frameworks for building sort of arbitrary state machines and running them on networks. So this is, okay, so that's what Ethermint is. Ethermint, what we typically call Ethermint, is an EVM module that interoperates with the Cosmos, with other modules on the Cosmos SDK, and allows you to build a custom network that will have at least some of its functionality exist within an EVM. And where we find there to be sort of product market fit for this use case is the product market fit comes from teams that have invested millions or tens of millions of dollars into software that uses the Web3 APIs, software that runs on top of Solidity. And what we find is that people are, as they are continuing their evolution as to like what kind of decentralized network their software should run on, they started out on Ethereum, and they either were burned by the politics of Ethereum or the high gas prices. They want more sovereignty and control, but they have a lot of sunk costs in the Ethereum ecosystem, and Ethermint is seems to be an attractive solution for a number of teams to do that. And that's what the vision that we've been driving.
That's great. Would you say that you all have a sort of similar architecture set reasoning for supporting the EVM? Could you talk a bit about Ethereum, if that's a live subnet or if that's an idea still?
Sure. Let me try to describe our strategy and vision here, and I want to avoid some confusion. It's very easy to get confused because we're engaged in a number of activities in the smart contract space. So first of all, we share with Cosmos the entirety of the vision, which is we would love to have, or we already have multiple virtual machines on the same platform. And so one of those virtual machines that we support today is the EVM. We support the EVM in its entirety. We are byte by byte compatible. The EVM is fault isolated. It operates in a separate process from the rest of the virtual machines that a given Avalanche node might be running. And it implements a fully ordered chain, just like the Ethereum chain, except it's much, much, much faster. So that's a pretty nice situation to be in. Like Zaki described, there's DeFi is the big, hot area at the moment. And in DeFi, a lot of these projects are hampered by the fact that they're just not, there just isn't enough throughput in the system for them to get done what they need to get done. So we provide that. So we provide very quick finality and we provide high transactions per second. If I may go on a tangent, let me mention another mistake that the Ethereum community overall, and in fact, I would say the cryptocurrency space overall has made. So the masses who are not technical, to them, the most important thing is transactions per second. So they do anything to get high TPS. And, I mean, we've seen certain projects lie about like millions of TPS, etc. But high TPS is not the difficult game. I can get you incredibly high TPS, right? Instead of making one decision, I decide on a huge numbers of transactions all at the same time, and then I multiply whatever my single decision. Suppose I had a system that was making one decision a day, and I was just deciding on one thing. Well, I decide on the phone book, and I consider each name in the phone book to be a separate decision. I went from one decision per day to millions of decisions per day, right? So you can lie about your processes, and you can get high TPS really easily. What is really difficult to achieve is low latency. And I'm really proud of what Avalanche is able to do. We keep advertising 1 to 2 seconds to finality. And what we really achieve in the network, in the test network today, is about 100 to 200 milliseconds. So it's like a blink of an eye. I don't know how many people could see me blink my eye right now. And that's about 1/10 of a second. So you click a web button, and in the blink of an eye, that web button actually can interact with the Avalanche network and come back to you with finality. This is not going to be achieved by ETH 2.0. It's just not going to get there. The sharding-based approaches all trade off latency. They're going down, they're pursuing the TPS, the TPS lure, and they're giving up on the most important thing, which is quick finality. Cosmos has this by virtue of being based on its own consensus protocol that's PBFT based. So once you've tasted quick finality, there's no going back. It's fantastic and it's an amazing thing. So all this is to say that we support the EVM on our contract chain. So we have the platform chain where staking occurs. We have the X chain where it's a DAG actually, where a lot of assets can exist and they're traded very, very fast. And then we have a fully ordered contract chain, which executes the EVM using AVAX as the gas token. So instead of Ethereum, you use AVAX, and you can just deploy through Remix or MetaMask, and and everything, all the toolkits work beautifully and without any interruption. Just think of the C-Chain as some kind of a test net, if you will. And you just sort of add it and then you use it. You don't even notice that it's not the Ethereum mainnet. So that's what we're doing. In addition to this, we floated the idea of an Ethereum spoon. And so at some point in the future, we are thinking of giving to every Ethereum holder some number of what we call Aetherium, ATH. Aetherium is kind of like ETH, but it's different. And we want to do it in a different sub-network. We don't have enough AVAXs to give them, but we can create a new coin. And especially if Ethereum 2.0 takes a while to materialize and people want to get going and they don't want to buy into Ava, they think the things that I've been proselytizing about don't, whatever, like they doubt it. Well, then that's fine. They will have for free some ETH airdropped onto them. We're thinking currently about how to do the airdrop. There are lots of interesting things to be done there. I want to make sure that small people, small Ethereum holders are incentivized to come check out what we've got. I don't necessarily want to make sure that the big whales are still whales. Ethereum whales remain Ethereum whales. That's not a concern of mine. There's only, but whatever. So that's something that I'm thinking about. And so Ethereum is coming. I'm not sure when we're going to do it. I'm not sure if we're going to do it. It depends on the community's response. So far, I would say it's been positive, save for maybe a couple of Ethereum maximalists, which I'm sad to see. I think maximalism is something I want to avoid in Avalanche. It's not good for any chain. I think it's usually the sign of decline is when the maxis appear. And anyway, so that's those are the two different things we do. We support the EVM in its entirety on Avax, and we also are thinking of Ethereum, which is a different subnetwork. But we're also supporting other smart contract chains as well. So one of the things we're doing right now is building a WASM-based virtual machine to supplement what we've got.
Thank you for that. So you guys both sort of described EVM as a virtual machine inside of the network. There's also what wasn't touched on too much from Zaki is there's some work underway, especially being pushed from ChainSafe side to also sort of think about what does a persistent network look like, Ethermint as a network. Some interesting conversations going around as well about how to do an Ethereum spoon effectively. Sunny Agarwal wrote a really interesting paper about gas drop, which is a bit more about the contract deployers who had high frequency. I sort of like the idea of maybe it being closer to the amount of gas that has been spent by different users as being sort of an interesting way to do spoons. Is there anything about the network topology of a persistent Ethermint chain, Zaki, that you would want to speak about, or the other sort of projects that we've seen sort of considering this move, like Aragon, and the way they're sort of thinking about building a persistent EVM chain in a internet of blockchain context?
So I guess, okay, so like one of the sort of meta philosophies of Cosmos is that we're just trying to bring down the cost of like incentive games. What we're seeing with like sort of yield farming and DeFi on Ethereum are still relatively simple incentive games, where you have like a few hundred lines of Solidity expressing like an incentive system. Things like Sunny's idea of a gas drop, all of these are very intriguing ideas. I think one of the things, and this is kind of, I think to a certain extent derailing where you want this to go, but one of the things I've been really thinking about a lot is sort of like when you are building a sidechain, or like one of the coolest pieces of technology that has sort of emerged in the Ethereum ecosystem that I really like is the validity proofs and roll-ups and fraud proofs sort of ecosystem of Ethereum sidechains. And one of the things that I've certainly been sort of thinking about and intrigued about in terms of something that I might want to build on top of Cosmos, or might want to come into existence, is an EVM zone that is really oriented towards sort of taking that technology and applying it in the sidechain space. So like you could have like IBC to StarkX, or IBC directly into like a ZK sync chain or something like that, so that we can avoid having to recreate all of that technology, which writing these like writing like basically the only Stark verifier that like exists right now is a Solidity Stark verifier, and rewriting that would be very expensive. And so that's like another sort of exciting potential use case of Cosmos tech.
So talking about sharing the technological developments from the ecosystem of Ethereum, makes me want to ask about sharing the economic resources of the Ethereum ecosystem. So to date, most of the sort of interesting projects and value and sort of a variety of assets are really located on the Ethereum blockchain. Zaki, can you talk a bit about what are the sort of bridging options that are available in the sort of like Cosmos ecosystem, interacting directly with Ethermint or to a SDK chain, what we're sort of seeing develop and where you think that direction will go?
Yeah, I think we're going to see especially sort of after Stargate when IBC is live. There are a variety of different ways of so our sort of flagship IBC protocol is really designed to sort of interoperate with sort of next gen proof of stake systems. I need to answer the door. Give me 1 second.
Maybe we can swap over and Gun, you can talk about what are to finish Zaki's thought, at least in the Cosmos space, IBC works mostly for fast finality chains, so sort of next generation. And if you want to move assets between Ethereum, you have sort of different bridge architectural designs. What are the properties of Avalanche that are required to move assets between Ethereum mainnet today or the assets that exist?
Okay, so we are also very excited about bridging technology. So we provide the ability to create assets on top of Avalanche, and we plan to support bridges such that Avalanche assets can be wrapped and represented on the Ethereum chain, and vice versa. Ethereum assets can be wrapped and represented on the Avalanche chains. This is particularly critical for some of the DeFi applications that are coming out on Avalanche. And we're really excited about that opportunity, because then suddenly what you will end up having is the Ethereum, DeFi started on Ethereum, and there's a lot of interesting work there, but it needs to it's trying to break out. The speed limitations of that platform are an impediment to a lot of DeFi projects. At least when we talk to them, they all seem very eager to explore other chains. So this is a low-cost way of connecting two different systems. There are also projects that we are partnering with that are going to be deploying directly on the Avalanche contract chain, the C-Chain. And not to confuse people any further, but the C-Chain on Avalanche is a little special. It has one modification, which is it can naturally deal with the assets created on the Avalanche X chain. So if somebody has a real estate token, then that can actually be sent as an input to a smart contract on the Ethereum side. And it's not like an ERC20, it's very different. ERC20s or other coins, you never really know what they're gonna do. We saw Uniswap get bit by this earlier, maybe 6 months ago, when they were supporting an asset, and that asset turned out to have a bug in it, and that was used to attack Uniswap. So Avalanche assets are different, and when they're in this format, they have the unique property that their behavior is constrained, so everybody knows what they're going to get, and yet you can operate on them with Solidity code. So that's something that we support on our C-Chain today. So that's a pretty full-fledged thing. So you have Ethereum, which is an external universe, and Avalanche. You can have wrapped assets in both directions once we have the bridge technology implemented. It's partially implemented today. And in addition, within the Avalanche ecosystem, assets can move and can be manipulated directly by Solidity contracts.
Thank you for that. Zaki, sorry to jump into the other in the middle of your sentence. I thought you were going to be gone for a second longer.
It was very quick, but yeah, so, I'm very excited about this idea of bringing sort of a DeFi-oriented peg zone. This is what we call, or peg functionality. The Altea team has been working on a very gas-efficient sort of architecture, but one of the things that we sort of, I'm very intrigued in is just all of the ways in which sort of Cosmos validators and sort of, zone subnet operators like are inherently a kind of distributed autonomous organization that can run multiple services. Those services can exist on multiple chains, and like sort of facilitate rapid experimentation. But like, one of the challenges I think that like, is interesting to me about the Cosmos ecosystem is, in parallel, we've been investing in multiple pieces of fundamental infrastructure, IBC, PEGI, some Bitcoin interoperability stuff. But, one of the things that I think the Cosmos ecosystem now needs to mature is a form of like decentralized go-to-market, of how to like collectively actually launch these things, figure out which chain that they're going to run on, whether or not we're going to upgrade the hub to support this. And like, one of the things that's very exciting about Cosmos is we're also a project that is sort of on the verge of sort of finishing what was in the Cosmos white paper. So the Cosmos white paper with Stargate will be sort of fully instantiated and fully exist. And now it is entirely up to the community to pick future directions and figure out how to actually like collectively launch new services and systems. And I think that's like one of the most exciting pieces of what's going on in Cosmos.
I guess with relation to that and the bridges is, there's a couple different sort of pathways for especially Ethereum bridges that look to be shaping up. There's this work on PEGI that's really been accelerated by Althea Network, and they plan to actually operate an instance of it. They also sort of hope to transfer the operation of that into the Cosmos hub itself. So this is sort of like a go-to-market story. There's also a similar capacity with Bitcoin, I guess, and I guess with each of those sort of designs, there are some variations and there's different trust assumptions. But I think with both of them, they really capitalize on the properties of Tendermint itself to sort of provide the claims of assets on either side. I guess I would be curious if with being sensitive to the time we have left, if you can talk about the actual architecture of a bridge requirement in the context of Avalanche. What are the, like, how does a bridge actually need to take place? Whereas I have a pretty clear idea how it works in the Tendermint context. You mentioned the tech is halfway done. Is that sort of still R&D as well?
No, yeah, I'm not quite ready to release our idea yet. So we're using a different set of technologies for our trustless bridge. So as you point out, it's actually very difficult to get bridges that you can know to be trustworthy. And so typically the bridge operator is in a privileged position. And we've done things to eliminate that trust, but I don't want to pre-announce what we did just yet. So if you will allow me, Billy, I think the listeners should keep in mind that Avalanche is a relatively young project. And so we started far after Cosmos, far after, Polkadot and so on. So we're catching up, and we've got an amazing array of different technologies that we're using for implementing our things. But I don't want to tip my hand too early, if you will. So there'll be
fair enough.
Hopefully
I guess I would also be mistaken not to mention that ChainSafe has been doing a lot of work on different bridge architectures, especially in coordination around Ethermint and other networks. So if you audience are interested in bridge stuff in general, that's a place to dig in. So we're coming up right at the sort of end of the general questions. I have some more here, but I thought maybe we should switch gears for a minute, try to take some questions from the audience and see if it fills up that whole half an hour. And if not, we can go back to some other questions that I've got. The very top one in the chat here is a question for both speakers. Context. Sharding provides shared security for all shards with some trade-offs, of course. Cosmos zones and even subnets are essentially side chains that they do not have shared security, and thus multiple zones, subnets cannot be used together as is without additional trust assumptions or full validation, which would defeat most of the point of having zone subnets. What approaches do you think are promising for adding shared security to zones, subnets, without sharding?
I can respond to this from an Avalanche point of view. It's actually quite straightforward in Avalanche. So, fantastic question, by the way. So it's absolutely true that these sub networks, they're kind of like shards in some sense. right? They partition your network into smaller components dedicated to different tasks, and they need to communicate on occasion. So when they need to communicate, Avalanche enforces the least possible trust assumption. That is, if subnetwork A is supposed to talk to subnetwork B, then and people want to have that communication take place, then subnetwork A does full validation of whatever factoids it needs to extract out of subnetwork B. It doesn't need to validate the entirety of B. It just needs to check what's going on at B, to check the property it needs to check. So does Alice have some fund in subnetwork B? It needs to check that question on the subnetwork B side, and that's what it does. For this, it needs to trust that subnetwork B has not failed. And that's the only thing it needs to trust. There is no third party. There is no other thing that weakens the protocol. It uses the full extent of the Avalanche protocol, which is very efficient. So nodes in subnetwork A communicate with nodes in subnetwork B, do the repeated subsampling thing to ensure that the property they're checking for holds in the target subnetwork. So that's our approach. It's very straightforward, very simple, easy to prove, is sound, and achieves everything we want it to achieve.
So one of the things that I think that I disagree the most with sort of sharding proponents is sharding proponents really think that like Ethereum uniform security is sort of worth the heavy price that you pay in terms of gas fees and all of this stuff. That shared security is like a sort of must-have property for blockchains. And my hypothesis has long been that like, you know, most non-trivial applications will require some oracles or some other sort of off-chain entities, that there isn't really that much benefit to a giant uniform security pool, and that really shared security is a very specialized use case and a very specialized technology. You know, I think like I'm probably most excited about is a technology called Lazy Ledger, which uses data availability proofs to sort of have subnets with mega blocks, you know, 100 gigabyte blocks, you know, are feasible in the Lazy Ledger schema, because just like in Avalanche lets you subsample consensus. Lazy Ledger lets you subsample blocks, which is a very cool innovation in my mind. And so I think that like it's very possible to build high scalable shared security systems for sort of niche applications that really benefit from it. But it's like a weird, it's a sort of a statement that people, it's an assumption that like this is a very important property that I think needs to be tested quite a bit more before we just sort of say the engineering overhead of building sharded system is actually worth it.
So the question also sort of touched on shared security though, and you didn't really talk about the way that there's sort of design moving with IBC to allow for cross-chain validation, which I would say is sort of most of the story that I've sort of heard around shared security within the Cosmos context.
So one of the things that I think a lot about is that you can additively, on top of the protocols of Cosmos that we've already built, add shared security, or add more sort of more complex punishment and enforcement mechanisms. So, you know, if you feel like, so there will likely be applications. I think like a really obvious application is like a Bitcoin peg zone. Whereas if you deployed it off of the Cosmos hub, you might want to be able to punish the operators of that Bitcoin peg zone if they like steal tokens from users. And so you can deploy, you know, with the coming CosmWasm technology that we're building, you could deploy mechanisms for tracking on the Cosmos hub, who's responsible for these things and what the correct behavior that you're expecting from them is. and then if they deviate from that behavior, slashing and punishing for atoms that are staked on the hub. And so I sort of view shared security as something that should be like sort of gradually introduced in the Cosmos ecosystem, and where shared security is most valuable, I hope that atoms become that the token that provides that shared security.
Thank you. The next question we touched on earlier, it's from Bruno. Hey, Bruno. Iqlusion is improbable in 10,000 validators. Okay, but you also need to discourage centralization of infra. 5,000 of those 10,000 run on AWS, and AWS goes down. Who ultimately pays for this disaster? We've sort of gone over this a bit, but maybe do either of you have anything else related to that topic you wanted to add in the context of each of the networks?
I don't have anything off the top of my head. We discussed, it was a great question. And I think we discussed it before. So we definitely do not want that kind of centralization on AWS. And actually, you guys don't see this, but the next message that I got privately from one of the participants says, I ran the Denali challenge, which is a testnet challenge on Avalanche, on an old Mac Mini from home, and was just a novice terminal user. Wasn't sure I could do it, but I did. It's still running today. So, you know, people can participate from home in a protocol like Avalanche. And if they can, then it avoids all of this centralization business. So that you need two things. You need one, the protocol has to be lightweight so you can run it from home. If you require mining rigs, you require energy expenditure, it's not going to happen for you. The second thing is the protocol needs to be able to accommodate large numbers of participants. This is an aspect of scalability that's often overlooked. And so Avalanche is, I think, the only consensus protocol that has this property of being able to accommodate tens of thousands to millions of participants. So I'm really happy about those two things. And I'm really looking forward to the emergent network. I would very much like to see people participate from home.
I mean, one of the downsides, I was going to say, one of the downsides of like a robust architecture or one that doesn't have necessarily integrity is that you have less assumptions about the performance, right? Somebody running the Mac Mini, you know, they just might have their home internet outage or something like that. So
that's correct. As people participate from home, then the performance properties of our network will go down, and I'm totally at peace with that. I'm totally okay with that. This is a game of building a decentralized network. This is not a game of building a complex Rube Goldberg machine, you know, and then I'm not going to name names here, but we've certainly seen coins, very, very highly ranked coins that are essentially centralized databases run out of AWS by a single entity, right? We've seen this many, many times. Zaki, let's just not mention names. I was about to mention names, but everybody knows what I'm referring to. They have their own army. And, you know, it's just not, that's the kind of trade-off I'm so happy to make, Billy. Sure, so maybe our finality times will go down from whatever they are today to half a second, to maybe a second. Even that I'm okay with, because decentralization is so essential. If this was a game of get speed at any cost, I could run a blockchain out of this very laptop and it would get 100,000 TPS, no problem. But nobody should use such a crappy system. That's not the game. That's not why it's difficult. It's difficult because you cannot trade off decentralization. That's something I would never give up. And so I want to see that take hold, and I would never, never compromise on that.
Zach, do you have anything to add to that topic?
What I would just add is like what I view as one of the bigger challenges is just actually how much the computing industry has abandoned the idea of running services out of your house or even your data center. Like, you know, the computing industry as a whole is so oriented towards like supporting cloud services and sort of treating the cloud as sort of the default deployment environment for every piece of software. And I think that's like one of the things that decentralization, frankly, struggles the most at. You know, for Diversify and StarkX right now, we are the only member of the data availability committee that was able to run on bare metal in a data center. And the reason, and what it took is like, we bought literally the highest performance hard drives that money can buy. And that's what it took to like sort of to run that service at the scalability that, was required. And so, for like a high performance DEX and stuff like that, it's so much easier to run in the cloud, and the ops of running in person are so much more complicated. Whether it's in your house or in a data center rack are so much complicated. And if cryptocurrencies can do anything, maybe it can create more of a market for sort of small scale, always on computers that are somewhat maintainable, and that would be a good thing.
So I want to riff off of that for a second, Zaki. So there are two things that kind of interfered with the peer-to-peer revolution. The peer-to-peer idea in the academic circles got hashed out in the early noughts. So 2001 and on, there were a huge number of peer-to-peer projects. They mostly did not go anywhere at all. And there were two reasons for this. One, the infrastructure was just not there. You got like 3 megabits to the home, and that was all you got. And you can't really do meaningful operations from the home if that's what you're facing. And the second problem was the business models weren't there. What's the business model of a typical service? I provide the service to you. You provide yourself as fodder. I collect data on you. I build a surveillance machine. I know everything about Billy Rennekamp. I then package that, whatever it is like that, your private information, unbeknownst to you, is being sold to hundreds of people downstream. You're being marketed and you're being abused in some sense. And it's kind of sad. And as a professor, I always felt bad because I was educating all these students who then would go on to build an element of this giant surveillance engine. And so there are two things going on now that give me hope. One is that we're breaking this business model. Cryptocurrencies break this model. They provide their own economies, their own incentive structure, their own distribution infrastructure, and suddenly you do not have to be part of the giant Googleplex or the giant whatever Facebook engine collecting data, building surveillance stuff. That's incredibly, I don't know what, empowering. And it's a fantastic thing to be living through. The second thing that's changing the world, I think, is the availability of fast bandwidth to the home. I can get a gigabit. That's what I've got in the closet right here. I'm in New York City. But there are people upstate New York, over by the Finger Lakes in the boonies, surrounded by horse farms, who are also getting gigabit. So this stuff is becoming commodity. And we saw this in Japan. We saw this in Korea. They're about a decade ahead of us. Everybody has high-speed internet. So with those kinds of connections, it becomes possible and feasible to run things out of your house. Now, what we kind of need is the software infrastructure that packages this. And all you got to do is just install Avalanche, install Cosmos, what have you. And it just kind of turnkey takes you to the next level of operating a service from inside your house. That's what I'm excited about.
Anything you want to add to that, Rip, Zaki?
Like the central, like decentralization of the physical infrastructure layer is like kind of the final frontier, I think, of decentralization, and it still represents kind of the biggest challenge.
Cool. The next question here is from TM. CryptoKitties killed the network in 2017. DeFi seems to be the hot thing at the moment until it isn't. Uniswap ETH is at it again with high fees. Can either of the two projects finally make a difference? Someday, hopefully soon, an inflow of retail institutional customers will come into this now tiny space. Can this space really scale up to billions of users, or is that some future project?
My impression, my expectation is that after Stargate, Cosmos will be ready to scale to billions of users. Stargate is October.
Yeah, so I would say the same thing. Avalanche is ready from the get-go. We're about to do our mainnet sometime very, very soon. And billions is not a problem whatsoever. And yeah, we were limited by, 3 TPS kind of systems or 15 TPS, and our finality half an hour finality for Ethereum these days if you want true finality, 15 seconds if you want make-believe finality. So suddenly we're going to find ourselves in a different regime where finality is within a second or so, and TPS is thousands. And I never thought I would see the day where our testnet, for example, achieved 6,500 transactions per second. That's 3 times faster than Visa. Okay, so I remember, I don't know if Zaki, were you there in Malta? We had financial cryptography conference in Malta, and I was there. Vitalik was there, Adam Back was there, Peter Wula was there. So the Bitcoin Core folks were there, and there was a discussion that around a very nice sort of just nice set of people, and prior to the craziness of the block size wars. And I remember Peter Wula turning to me and saying, "Look, we could make the blocks bigger. It's possible to make them slightly bigger, but how big can you make them? Make them 2x maybe. You could probably make them 4x maybe, but at some point you're going to run out and you will never be able to compete with Visa." And he was right. With that technology, you can't get there. With proof of work, you cannot get there. But these new technologies give us this ability to achieve enormously big leaps in both finalization time and throughput. So yeah, next billion is not a problem. And there is a lot of assets out there on Wall Street that are just sitting on books, and they're hard to trade. And all you got to do is unleash them. All you got to do is allow people to go and buy and sell them, to give them higher reach. And that's one of the main things we're going after with Avalanche.
Cool. So we have a question from YouTube from Nathan. It says, is shared security still being developed? I was talking to Cent devs and they're thinking about using shared security for their hub. When would that be available? So Zaki spoke about this briefly earlier, but maybe actually I can take this one just because at the ICF I've been coordinating with a lot of entities around this topic. Shared security still is quite a vague term inside of the context of the Cosmos Hub. So Zaki sort of gave a conceptual thinking for it in a way that it's slashable events on the Cosmos Hub that are coming from external networks. So essentially external networks being secured by the value of the atom on the Cosmos Hub. In terms of timelines, I would hesitate ever to give a timeline again. But there's, I think, one claim that this needs sort of heavy research and mapping out. I would imagine that happening over a 6-month to a year period. There's some researchers at Lausanne who are working on this. Chris Goes within Interchain GmbH has also begun sort of more seriously approaching the topic. At the same time, there's some work being done to implement sort of early ideas as soon as possible. So you might actually see an early version of it in the next couple months, although I would say that it's one that is sort of like rapidly iterated and might be approached with caution compared to what probably should take place, which is sort of iterative research approaches. At the same time, there's work on optimistic rollups and zero knowledge rollups, which sort of provide similar capabilities. They're sort of like poor man's shared security that are being pushed along by a couple different teams. Lazy Ledger is sort of applying pressure, especially to the optimistic rollup scenario, because they sort of require that architecture and the capabilities that Lazy Ledger provides that Zaki also mentioned in the context of this question. I mean, this question is literally posed towards Cosmos and the hub, but if in a similar capacity there's anything to add to the shared security question around Ava, and I also encourage you to contribute.
No, that's not, it's not something, that's not the direction we're too focused on. We're focused on making our core chain go as fast as possible. And we're very much focused on going mainnet as soon as we can. That's where we are.
Cool. Another YouTube question from Gary is, what type of time frame will these bridges start to happen, do you think? Thanks.
For us, it's fall. It's October, November.
Zaki, do you have any, you daring to take any time estimates on ETH bridges, Bitcoin bridges within the Cosmos ecosystem?
I would say more like Q1 2021.
Cool. So that's all the questions that we've gotten from the audience. if anybody wants to submit one right away, I can take it. Otherwise, I can revert back to a couple questions that I still have. We've only got really 10 minutes left here, so.
And my voice is about to go out, so yeah, but yeah, I think I can last 10 more minutes.
Okay, so maybe I can give one last question, which is, what are your all's worst case scenarios? What are your nightmare scenarios that keep you up at night for each of your networks? I remember in the paper you mentioned round adaptive adversary. Is this the sort of scariest scenario for Avalanche? And if so, could you maybe talk a bit about that in a way that doesn't damage your market cap?
I'll be frank with, this is a great question. I'll be frank with you. My biggest concern, the thing that keeps me up at night, is that I'm not moving fast enough. That's my only concern. So the adversary model in Avalanche papers is incredibly powerful. So we assume that the adversary is able to see every single node and control a very large fraction of Byzantine nodes in full. And even with that ability, it's what it can do is limited. And it turns out Avalanche is very, very robust. It can withstand more than 51% of the network being compromised. So nobody else can say that. We can do this. If we target, let's say we target 33% to be comparable to other systems. If the attacker is 34%, that doesn't impact Avalanche at all. What does affect, well, sorry, I should be very precise. If we target 33%, what Avalanche will tell you is something like, here's what you should do. Here's the number of times you should subsample the network. And at the end of this process, you are guaranteed that there will be no safety violations for the next 20,000 years. The mean time between safety violations is going to be 20,000 years. That's the precise way to say it. If the attacker turns out to be bigger than you thought, so you targeted 33% and the mean time between failures of 20,000 years. Suppose the adversary is 34%, or let's say, suppose the adversary is 40%. It doesn't mean he's going to win. With every classical protocol, it means he's guaranteed to win right then and there. But with Avalanche, it means that he blew through your mean time between failures, but his own success ratio is actually pretty small still. So if he's only 40% and you targeted 33, what he would do is he might end up taking you from mean time between failures of 20,000 years to 2,000 years. That's a big reduction in your security budget, but it's not the end of the world. So security is not my biggest concern at the moment. My concern is execution. We've been moving very, very fast, but the DeFi space is full of very bright people doing really fun stuff. And I want Avalanche to be out there. I see a whole lot of well-intentioned efforts kind of running into difficulty on different platforms. And I want to take them onto Avalanche. And I worry that people will end up deploying something really amazing on a crappy platform and it'll stick. And that's my only real worry at night. So that is something will end up making this crappy technology we've got today ossified. And it will be very difficult for even Ethereum 2.0, for example, to change out of Ethereum 1.0. Or something will happen and it'll be very difficult for us to move away from proof of work systems. So that's my concern. Other than that, execution, speed of execution, that's what I worry about.
Zaki?
So I would say what worries me the most is, Cosmos was able to do some really amazing things in terms of quality assurance, in terms of building the platform. We were, in 2019 when we launched, we were really like one of the unique few platforms that was not just like Bitcoin or Ethereum fork, but like an entire ground up new software development stack. And we invested large amounts of money in audits and in this testnet program and in this simulation and fuzzing framework. But now we're this decentralized swarm of entities that are building Cosmos instead of most of us working for a single company. And, organizational complexity is not the friend of writing bug-free secure software, but is the friend of decentralization. And And so things are going well as we sort of matured into this new structure. But probably the thing that worries me the most is that we are not how are we going to build up the ability to sort of exceed the quality of assurance guarantees that we've been able to maintain so far while dealing with the reality of being a multi-entity ecosystem.
Great. So we have 4 minutes left. I want to say thanks very much for coming. And if I can, very quickly, what do we need to do to make Avalanche and Cosmos chains talk to each other, you all? IBC's there. Are the properties of Avalanche sufficient to support IBC?
Oh yeah, we could easily support, like, our bridging technology is versatile enough that we could cross assets from Cosmos to Avalanche very, very easily. We could wrap in both directions. So that's something that I can't say can happen by this fall. By this fall, we're targeting Bitcoin and Ethereum and ERC20s, but shortly thereafter, in the next 6 months after that, Q1 2021, that's something we could do. It'll be interesting. Yeah, I mean, it's all a function of just how much value there will be in facilitating that kind of bridging.
Zaki, I guess it's hard for us to say anything about IBC compatibility with Avalanche at this point, but do you have anything to add to that topic?
Oh, I mean, I've had some really good discussions with the Avalanche team about what an IBC integration into Avalanche would look like, and it's definitely something that I'm excited about and I'm enthusiastic about, and I think is definitely doable. I don't know. Again, I'm not going to commit to timelines, but because like the bridge that's probably moving the bridges that are kind of like we're working on a grandpa to Cosmos bridge that seems pretty doable, and then I think it's sort of like we got to make some assessments about what sort of alternative consensuses are actually live and have mainnets and are decentralized and are sort of interesting to build IBC adapters to. But I think an IBC adapter to I imagine it'll probably be like a specialized subnet initially inside of on the Avalanche side and the Cosmos on the Cosmos side, and you can just make all of this talk to exchange messages back and forth.
Cool. And in lieu of that, we can look forward to the bridge architecture that is going to be something we can learn about in the future.
Mm-hmm.
Cool. I've dragged you all on through 2 hours of riveting questions. I really appreciate you taking the time and giving such thoughtful responses. Thank you to the audience for posing questions. Thank you so much, Kelsey, for organizing all of this.
Thank you so much for having me. This has been it has been a delightful conversation. Zaki, fantastic to see you. Fantastic to get a chance to chat with you. And many thanks to the audience.
Hopefully we'll see each other in real life when seeing that happens again.
Can't wait. It'll be great.
Bye.
Kelsey, can we hang up or are we supposed to stay on?
Feel free to